Like sets, sorted sets also provide the ability to perform set-based operations. Unlike sets, sorted sets provide the ability to only store the results into another sorted set. You cannot get the result set from the command alone. Sorted sets provide the ability to perform an intersection and union, but not a difference. These commands are equivalent to the set commands, so we will not cover in any detail here. In a later chapter, we'll dive into the complexity of how you compute the score to evaluate across elements with the same value but different scores. So, what are some typical use cases for sorted sets? Let's take a look at a couple of obvious ones. Consider a leaderboard for an online game. The value of the element is the user ID or their screen name. We have 6 player entries and their respective point totals. The point total is the natural score we want to order by. When Jane gets a 50-point bonus, we can use zincreby to update her score and zrevrange to get the top 3 for the leaderboard. In addition, if you only want to keep the top 3 and not the entire list, you can reduce or cap the size of the list with zremrange by rank. Zremrange by rank removes the inclusive range of elements specified. So for the top 3, we need to start at the 0 element, which has the lowest score, and we want to include up to the 4th element in the list, preserving the top 3. As we saw with lists, it's simple enough to create a queue or a stack. You can pop from either end of the list to achieve the processing order you require. A specialization is a priority queue, where a value is associated with each element which governs the ordering or priority in which the elements are retrieved for processing. Sorted sets are ideally suited for this purpose. The score can be used as priority. Elements can be added in any order as we see here. The score maps to the priority. We are using a simple 1, 2, 3 priority. To get the next item to process in priority order, we use zrange. And to remove the item from the list, we use zrem. These statements can be combined in a transaction to make it a safe operation. And we'll talk about transactions in a later chapter. So, to recap, sorted sets are an ordered collection of unique values. Each value has an associated score, which is used to store the values in ascending order. The sorted set can be traversed in ascending or descending order and can be manipulated by score value in lexicography. Finally, sorted sets also provide the ability to create a union and intersection results from a number of other sets and sorted sets. Example use cases for sorted sets would be a priority queue or a leaderboard.